Hello and welcome to our webinar here today. Thank you very much for being with us, whether it's your morning, your afternoon, or your evening. We really appreciate you being with us today. In today's webinar, we're going to discuss how you can learn how to detect millimeter ground movement from spaceborne radar using Catalyst's new ground displacement workflow, so our new microservice on the UP42 platform. Before we get into our actual webinar, we just want you to understand how to engage with us. So all of your lines are muted during the presentation. However, if you have a question at any point in this webinar, please go to use GoToWebinar's questions panel. So you can find this in the main GoToWebinar panel, control panel. Click on the questions panel here, and then you can type in your question at any point throughout the webinar. We will do our best at the end of this webinar in order to answer all the questions that are asked. And if we don't get to your questions in this live webinar, then we will be sure to post the answers to your questions with the recording on our website. I'd like to just take this moment now to introduce our speakers for this webinar. So we're very excited to have one of our special guest speakers, Jorge Fernandez, who's the head of product from UP42. Welcome, Jorge.
Hi, everyone. Very happy to be here. It's a pleasure to be speaking about what UP42 and Catalyst is doing together.
Wonderful. Thank you so much, Jorge. And of course, we have no stranger to these webinars. We have Griffin Williams, who's one of our solution engineers, and he will be responsible for showcasing the demonstration today. Welcome, Griffin.
Thank you very much, Sean. Looking forward to it.
Wonderful. And then myself, Sean Malamed, I am a product marketing manager here at Catalyst, and I will be your host throughout this webinar today. And once again, just on behalf of the three of us, we really appreciate you spending your time with us here today.
Alrighty.
Okay, so we're just going to spend a moment to go through the webinar agenda. So we're going to start off with just a brief introduction about Catalyst. We're then going to move into a short overview about the Catalyst microservices, which we're going to be discussing today, and at which point we will also introduce our new microservice, which is now available on UP42. We're then going to hand things over to Griffin, who's going to showcase our Python API and provide a demonstration using Jupyter Notebook in terms of how easy it is to access and calculate ground deformation using Insar measurements, Insar techniques. We're then going to hand things over to Jorge, who's going to showcase the benefits of building geospatial solutions on the UP42 platform. And then we'll finish off with a brief question and answer period. So once again, if you have any questions at this point or at any point throughout the webinar, please feel free to type those questions into the questions panel, and we'll be sure to get to them in the Q&A session at the end of the webinar, or we'll post them on our website. So very briefly, Catalyst is a new brand that's been launched by PCI Geomatics. We launched our brand back in October of last year. And the whole purpose behind this is we want to showcase that we can make Earth observation information and data more readily available to a wider audience. So of course, we're going to continue to showcase how the technology can improve and become more easily accessible to both geospatial experts and professionals, but also to non-geospatial experts and professionals that are looking to take advantage of this information in order to provide and ensure a more sustainable and manageable planet. At Catalyst, we have four main product lines right now. So we have Catalyst Professional, which is our desktop product, which has subscription-based options. And it's designed for the geospatial professional who is focusing or specializing in remote sensing, photogrammetry, and Earth observation sciences with a rich stack of algorithms and capabilities for specifically those kinds of applications. We then have Catalyst Enterprise, which is our distributed solution for performing production-based workflows, and it's designed to be able to provide automated workflows in an end-to-end or integrated environment. We then have two new products lines, which we're going to be showcasing as well. So we have our Catalyst Insights, which is our web-based information service that is designed to be able to provide end users with the information that can be extracted from Earth observation with very little know-how or expertise is required in the actual industry or production of that data. And then finally, we have Catalyst Microservices, which is actually the focus of this webinar, where it's really designed to be able to access and perform processing in the cloud. As mentioned, the focus of this webinar is the Catalyst Microservices. And really, this is a new capability that we've now launched. We're essentially converting our rich algorithm over 750 different algorithms and workflows, and we're converting them into these very compact and individual microservices that are highly portable and allow you to more easily process Earth imagery on the cloud. They're really designed as these individual containers where they contain everything that's required to perform the process, including the security, including the runtime, the dependent libraries, and so on. So all of those dependencies and requirements are already built into these microservices or these containers, and this allows us to provide standardized building blocks that can be easily integrated between different or within your workflow. It doesn't require any, or it can work on any operating system, so it's really interoperable for a variety of different types of computing capabilities. There's no installation required, which is another large advantage. So you can really just call the API and point to the data and begin processing and get your results. And then finally, it provides that price predictability because we offer consumption-based pricing around these microservices so that you know exactly, based on the amount of data that you're going to process, how much it's going to cost to process that data, which is very important for a lot of algorithms, or sorry, a lot of platforms, and creating a variety of different solutions for end users. So with Catalyst Microservices, we're deploying them on major cloud partners such as Amazon AWS, Microsoft Azure, as well as industry-specific cloud partners. And as you can see, poking behind that cloud there, Up42, which is going to be the focus for the remainder of this webinar. And we're very excited that we've now launched our first microservice on the Up42 platform, which is our ground displacement microservice, which can now be accessed as of today on the Up42 platform. And we have a special offer at the end of this webinar that we're going to be showcased so that it makes it even easier for you to give this new microservice a try. So this new microservice is designed around differential Insar, so our differential Insar workflow. And it's really there to detect ground movement, and it's capable of detecting ground movement as precise as a few millimeters. As you can see in this image, it'll highlight areas in a field of view. So essentially every single pixel on the image will be able to, will provide you with information about the ground movement. And it's really designed to look for very precise or very small amounts of ground movement or displacement on the ground. And you can provide a stack of imagery in order to calculate what's known as cumulative ground displacement in order to identify, look for larger amounts of ground movement over time. And this can be very important for the application that we're actually going to showcase today in terms of being able to identify potential risks of say things like landslides. The inputs for this particular microservice is you need an Insar pair. So you can provide multiple inside pairs. You provide a stack of overlapping SAR data that's captured on the same orbital track in order to process this data. So it actually compares the two images and looks for the deformation between those two images. And it continues to do this for a stack of imagery so we can calculate what's known as the cumulative displacement over this stack of imagery that's provided. The output from this, as mentioned, is really a field representation of the deformation. So every single pixel on the overlap area between those two images is going to be provided with a deformation measurement. And this deformation measurement can be used to detect where your ground is starting to subside down or where you're starting to get uplift. Some of the applications around this include detecting geohazards or early warning signs for geohazards such as landslides, which is actually the application we're going to showcase today. It can also be a great tool for a tip and cue concept, such as identifying general trends where further investigation is required, and then of course also glacial tracking. So with that, I'm going to hand things over to Griffin, who's going to go through our case study and demonstration today.
All right, thank you very much, Sean. Just getting the webcam, there we go. All right, so today for the demonstration, we're going to be looking at a case study of a landslide that occurred in the Rishi Ganga Valley in India earlier this year. Unfortunately, this landslide resulted in at least 70 lives were lost and an additional 136 are missing and presumed dead. So really a tragic accident that has happened earlier this year. But what we're trying to look at in this particular use case is, could we have mitigated those impacts using Earth observation data and different Earth observation analytics? So for this workflow example, we're using Sentinel-1 imagery and the Catalyst Insar ground deformation microservice on UP42 to find out if there might have been any early warning signs that we could have noticed prior to this event happening. So on the screen now we have, a before and after photograph of the region from an optical spot 6 and 7. We also have on the upper right-hand side the UP42 web interface for selecting which Sentinel-1 scenes are going to process, and then also the Catalyst microservice on UP42. And then in the bottom right-hand corner, a little highlight of the results showing that there's some significant displacement that was occurring in that region in the weeks prior to the landslide. So now what I'm going to do is just stop sharing this presentation and go into a Jupyter notebook. So today in this example, what I want to show is running this ground deformation, ground displacement process from Catalyst using UP42's Python SDK and Python SDK. So to begin this process, naturally, we need to set up our Python environment. So in order to do all of the processing, so acquiring the Sentinel-1 images and performing the Catalyst differential Insar processing, all we need to do is import the UP42 library, and then I'll show you how we use it later. The rest of these libraries are open source, and I use them for the purposes of display and this demonstration. But really the focus is on this UP42 API library. So to do this processing workflow, the first step, we need to authenticate ourselves with UP42. And then once we've done that, we can set up the different tasks to create a workflow that will be able to run as our microservice. So to do the ground displacement, there are two tasks required. There's the SoBlue S1 SLC full scene, which basically is a task to get the Sentinel-1 dataset in SLC mode, and then we will apply the Catalyst Pro INS stack task, which does all of the differential Insar, so the ingest of the Sentinel-1 data, the co-registration, the phase unwrapping, and then of course the final stacking of the data to compare the phases, to compare the to determine displacements and displacement velocity. So we add those two tasks to our workflow, and then we specify the coordinates, so the area of interest that we're working with, and which Sentinel scenes that we're using. So in this case, for demo purposes, we've only used 2 scenes here, but this type of analysis would certainly be enriched with a larger stack of data. So, more images in the months and weeks prior to this landslide occurring would give us a better understanding of, as Sean had mentioned, identifying changing velocities, which could help us identify that there's a potential issue in that particular region. So once all that's configured and we run this cell, we get the output that our authentication was successful, which is great. And then we've added our workflows and added the tasks to the workflow. So everything is getting all set and ready to go. So the next step is, with the configured workflow, we want to quickly run a test job to verify that the data is available and that our algorithms and processes are all configured correctly. So that's what we're doing in this code block here. We're running the test job version of the workflow. And this is sort of like a dry run, a quick little check, a fail fast principle, if you will, to just double check to make sure that the data is there, that there's overlap with our AOI, and that we shouldn't have any problems when we actually run the full end-to-end process. So as we can see, that's been returned successfully, so that's great. And then we can move into actually running the job itself in full sort of, I guess, production mode. So we can see, it gives us a little readout of our parameters, and the job is running, and we're tracking its progress, and you can follow along with that. As you can see here, I've already run this. I've pre-generated the results just to save on time. And then after that, we've run it. Now it's time to download the data, so we're able to download the results to our machine. And that's really all it is in terms of running this ground displacement workflow on UP42. It's simply setting it up with the appropriate tasks, selecting which imagery you want to use, running the data set, and then downloading the results. So we have some examples. I'm just going to highlight a couple of files here. Let me scroll down a little bit, highlight a couple of files here that are generated. So we have a cumulative displacement stack of coherences TIFF file, a velocity stack file, cumulative displacement statistics, and a cumulative displacement stack file as well. So those are all the output products from that from our differential Insar workflow that can be analyzed and assessed to measure things like the cumulative displacement, the velocity of change, etc. So what I want to do now is quickly in Python, in this Drupal notebook, show you an example of displaying and rendering some of those products that we've generated. So this is where we're getting now into using open source tools for the plotting and visualization of some of these results. So the first one I want to show you here is I'm going to generate a cumulative displacement map. So this is again showing the cumulative displacement within our stack. So in this case, of course, we're only looking at 2 images. So if you had more images, if your stack was 10, 15, 20 images deep, then this would give you a more kind of a better understanding of a long-term trend in the cumulative displacement. So areas in red have higher displacement towards line of sight of the sensor, where areas in the green have little displacement or actually a negative displacement in terms of line of sight from the sensor. So that's the cumulative displacement product that we generate. The next product I want to show is the coherence layer. So this coherence layer can be used for quality assurance purposes. So areas of high coherence, so areas that appear more white in this image, have a higher level of coherence, so we can have more confidence in the quality of our results, whereas areas that are darker have less coherence, and therefore we can have less certainty in the accuracy of the result in that region. So this is just a useful and a powerful way to quickly get an understanding of the quality of the result in terms of its coherence. And then the final thing that I wanted to show is to clip that larger cumulative displacement raster down to a smaller area of interest, specifically focusing on the region in which the landslide had occurred. So there's a lot of code in here. Basically, it's all just for reprojecting, clipping, subsetting my imagery into this clipped cumulative displacement image, which I then will plot using a similar kind of color ramp to what I'd used for the previous one. And again, we can see here in this region where the landslide occurred that there's been some significant positive displacement in the weeks leading up to the landslide. So this is, again, a fairly a simplistic version for demonstration purposes. Adding additional images to the stack can make this this analysis more robust and can help us identify potential early warning signs, and we could be alerted to the fact that there's abnormally fast displacement occurring in this location, and then that could let us know, okay, we should send out some additional people to do like a ground assessment or something like that, or to make sure we're focusing more on this type of a region. So once again, this is a quick example of how to generate these products using the Catalyst deformation workflow microservice on UP42, accessing it via the Python SDK. And with that, I'm going to send it back to Sean. Just let me pull up the presentation again here and then send it back his way.
Wonderful. Thank you so much, Griffin. Really appreciate that. So as you were presenting there was a few questions that came up, which we'll be sure to get to your questions in the Q&A session at the end of this webinar. But what I think is really important at this stage right now is to just discuss some of the validation, some of the ground validation that we've already done with this algorithm. So there was a validation study we did over Cold Lake, Alberta with MDA using RadarSat-2 data. And we did this using corner reflectors along an oil and gas pipeline. And we compared the ground displacement that was calculated by our Insar algorithm versus the ground displacement that was measured using terrestrial surveying equipment GNSS stations. So as you can see here on this trend line or on this graph, we have in blue is the ground deformation in millimeters that was measured based on this algorithm here for different for this individual point for the specific corner reflector here. And as you can see, and then in comparison, here are the measurements or the ground deformation that was measured around this approximately the same time using the GNSS stations. So the reference, and this is all in millimeters. So in this case, as you can see, the trend is very much corresponds to what was measured using the terrestrial surveying equipment, so much so that we have an R-squared error of about 0.9938. So you can see that we have the capability of being very accurate in terms of the ground deformation that's being measured with the Insar techniques and algorithms using space-based radar versus the actual ground truth or validation that we performed using the terrestrial surveying equipment. Now, another thing that's also important that I just want to quickly discuss about this. Now, Griffin alluded to this in his demonstration, which is using a stack of imagery can give you a lot of individual insights. So Griffin showcased in his demonstration a visualization of ground deformation that was calculated between two images. Now, when you have a stack of imagery, you begin to build up a trend line to identify the amount of movement that's occurring over time for different measurements or different pairs that you've captured. And this is essentially what's being illustrated in this graph here. And this can be done for each individual point or pixel on the raster. Now, what's really valuable about this for an application such as identifying ground movement for as a precursor to a potential landslide or a variety of other applications is that you don't want to just look for ground deformation occurring, because there's a lot of now natural ground deformation occurring anyways. What you're really starting to look for is, are you seeing accelerations in either an subsidence or uplift? So an unnatural accelerations in a particular area that might be really more of a warning sign. So let's say, for example, if this trend line, as you can see, it shows a consistent trend up. But let's imagine we had at some point a rapid acceleration in, or an increase in the velocity of deformation. Now that would be a very strong warning sign about a potential issue, or something that's worth investigating further. So that really just comes back to the concept of, and the importance of using a larger or deeper stack of SAR imagery versus just two pairs, or a single pair, as we showcased in this demonstration. So something else that I just want to quickly touch on is a little bit of Insar basics. So think of this as an Insar 101. Many people in this webinar are quite familiar with Insar techniques and how it works, but there's also a lot of people in this webinar that we understand this might be your first time being introduced to Insar. So we're not going to go into too much depth about the math and the techniques and the science behind Insar, but we just want you to understand how we're able to detect millimeter level movements on the ground using a spaceborne aperture. So really what this graphic is representing is two different passes of a satellite. So on the first pass of the satellite over a particular area on a specific orbital track, and that's an important part of it, is that it captures, it sends out a set of radar beams to capture that radar image that essentially you can process through the algorithm. And when it sends out the radar beam and it reflects off of a feature on the ground and goes back in and is received again by the satellite, it's able to measure where along the wavelength, so the phase along the wavelength, where that beam was detected, or where that beam was received. Now on the second pass along that same orbital track, so a few days later, it's able to then send that same radar beam, or send another beam out from the same position. So imagine this is on the same position here. It then sends that beam out, and if the ground has moved, say within a few millimeters or a few centimeters, it then when it receives that radar beam back for that same feature and within the line of sight, it can calculate the difference. So now there's a phase shift essentially of where that radar beam is detected here. And now that difference, that calculated difference between the phase of the first radar beam and the second radar beam for that same pixel can help us detect that millimeter level movement based on the line of sight delta. And this is all based on the fact that these radar beams are really, the wavelengths are quite small. So for example, for a C-band, it's approximately 5 centimeters, which means we can detect, very small movements quite precisely. Okay, so this opens it up to our first survey question. So we want to get the crowd and get the audience involved now. So I'm just going to launch our first poll question, and we just really want to understand, why are you interested in measuring or monitoring land deformation? So there's a couple options here, so you can select one. So maybe you're interested in just research. Perhaps you're interested in public safety or environmental monitoring, similar to what Griffin showed in the demonstration. Maybe infrastructure monitoring, that seems to be a very popular topic. Something different, so if so, please, we'd love to hear what you're interested in, and please specify that in the questions panel. And or perhaps you're really just here to learn, you find this to be an interesting topic, and you're just excited to understand a little bit more about what's possible in terms of how we're able to detect these kinds of very precise movements using an aperture so far away. So we appreciate you voting. So we have over half of the participants have already voted. And it looks like 30% of you so far are interested in research. We have a good split around public safety and infrastructure. So 18% right now interested in public safety, 19% in infrastructure. And then we have a majority, or a small majority of you that are really just here to learn. So approximately 34%. So we'll keep the poll open for another 10 seconds. So if you haven't got your your answer submitted, please do so in the next few seconds before I close the poll. We'd really love to hear from you in terms of what you're interested in. Okay, so I'm just going to close the poll in 3, 2, 1. All right, let's share those results. So as you can see here, we have about 31% of you are interested more from a research perspective. We have an even split, so 17% are interested in public safety or environmental monitoring, another 17% interested in infrastructure monitoring, and then we have a number of you that are really just here to learn. So we really appreciate that. Okay, so with that, we're going to hand things over to our special guest speaker, Jorge, who is going to walk us through some of the benefits of building geospatial solutions on UP42. Take it away, Jorge.
Yeah, thank you, Sean, and thank you, Griffin, for the beautiful demo. Yeah, good morning, good afternoon, everyone. It's just to say that it's a real pleasure for us to be here, not only doing this webinar but also partnering with Catalyst, with a company with such history on the analytics space and beyond, and we really see the value of bringing not only this microservice or processing block, as we call them, into our platform, but a lot more, right? I'd like to walk you through the benefits of building geospatial solutions on UP42. And I would also like to start by presenting you who we are, right? So UP42 is a relatively new company. We are a developer platform for and marketplace to derive insights from geospatial data at scale. I mean, every word, as you can imagine, on that means something to us, right? But you know, at the end of the day, what we want to do is to take data, take processing, and make it available to the developer community that we believe is gonna build the geospatial products of the future. And we see that there is a strong need to derive insights from this type of data and also to do it at scale. I'm sure our friends at the Catalyst also agree, we are at the verge of a change in how geospatial data is being used and used at scale. So we are a smaller team with 55 people from 24 countries based in Berlin. I'm myself originally from Spain. We are a company founded and 100% owned by Airbus, but we have a agnostic marketplace. So we try to bring data and processing partners from everywhere. And we also had the luxury of being incubated by BCG, Boston Consulting Group. What industry problems does UP42 try to solve? Why are we here? And I hope that those that are here to learn, but also those that already have experience working with this type of data, is that there is way too many technical and commercial constraints to using geospatial data and algorithms in general, right? Both at scale, but also even for testing. And it's just true that this is making it harder to get this type of technology applied downstream, right? Like to really unleash the potential of this technology, just like maps and vector data did it, just like machine learning is effectively everywhere on many of our applications today. So what are the three things that we see? One is the data ecosystem is fragmented, right? There is large commercial and contractual complexities that make it pretty hard to get access to this data. And also the mechanism to access that data, it changes quite a lot from provider to provider. That is a problem. Then it's also hard to build and distribute algorithms. Well, for Catalyst, with a company with such history, they already have their place and their channels to do so. But it's no easy, it's no straightforward to commercially distribute this type of algorithms more in general, right? It typically ends up with great minds working on extremely good algorithms, but that are developed in-house, that never see the light of the day in terms of being open to a broader market. And sometimes those are, you know, heavy fitting specific cases. Then it's also hard to scale efficiently, right? I mean, we do have a developer first approach, but in general, we know that this industry does not have such approach, and that to maintain and build your own scalable and efficient cloud environment, it's expensive. And there is one more issue, that is, how can you even start exploring all of this technology? It is not easy. So we've looked at all of these problems, and we've come up with what we believe is a good solution to it, right? We are trying to remove these barriers that unlock this technology in general, both just the data, the processing, and the infrastructure to run it. We want to unlock it. So what are we doing? One, we operate a marketplace for geospatial data and algorithms, right? So our customers can discover, access, and order data from any of the leading geospatial companies. And here we have Catalyst with us, showing how they integrated their first microservice, or again, how we call it, processing block, so that it is available to our customers that might be looking into doing similar type of use cases, that they might want to use this grand deformation algorithm to run something else on top. And I like that Sean, you mentioned this as well, that you do have a very transparent and simple pricing approach. So we want to give everyone the clear picture of what things will cost. And then also partners, again, the people that make Up 42 possible also get obviously a share of what they do. Then, as I said, we also have a simple UI to discover and do rapid prototyping, or simply to quickly test and find the right combination of data and algorithms that fulfill your insights. Anyone, and I encourage everyone to go and try the platform. Anyone can search and preview data across multiple providers, order it, and even get a request for tasking data, which is quite unique. Then it's as easy as that. You can get the data and effectively connect it with processing blocks that pre-process the data and act on it, giving more insights to the customer. And all of this without really needing a single line of code. But that is what makes it very interesting, because behind the scenes, there is a workflow engine and a scalable infrastructure that allows for the, we said that on this demo, we had 2 scenes. I will show you later on an example where we have almost 500, and you need to have some power to do that. Our platform really ensures that data algorithms compatibility, once the data arrives from all of these many different data providers, can interact with each other. And the infrastructure that you use to run scales up and down as you need. And then, of course, because we are developer first, we have these platform APIs and SDK. So once you have your basic workflows in place, our customers, the developers, can access the full power of Up 42 by integrating the system, our platform, directly into their products, and even using open source Python SDK that include a lot of information to support how to navigate the product. That's also something that we've been working on for the past couple months. We're gonna have a refresh documentation that is gonna really make it very easy to get to do what Griffin has done in a way that it will really take you no time. Okay, I'll start to be a little bit faster, but our marketplace has a lot of data. We have commercial data and open source data. Examples here from Pleiades, NextMap. We also have vector data like AIS data, and then we also have weather data. And this list continues to grow, and we continue to work with our partners to bring more and more data. And we also obviously have a robust ecosystem of open source data that effectively we know that this, together with the commercial data, at the end of the day, is what builds most of the use cases. Then here we also have a number of algorithms from a number of partners. This is what it will be the analogy of the microservices. We have processing algorithms that work on data preparation and pre-processing. We have indices and pendant statistics. Here is where we fit the ground displacement algorithm from Catalyst that is now available on the marketplace. And we also have AI and ML object detection classification algorithms that do a little bit more behind the scenes to get you to the insight that you need. And of course, again, this list, it's meant to grow. We hope that customers find value on the processing that we offer. And Catalyst also finds an interesting channel through us to offer more and more algorithms through App42. Something that I also want to mention is that if there is custom processing blocks, you can also do that and not necessarily offer them on the platform, but just use them for yourself. Now, I want to show this again. I want to emphasize the fact that you can go from a no-code workflow in the UI to run that same workflow at scale using the API. And again, this is an example. I encourage everyone to go test the platform by itself. But we had a classic example of a company that wanted to run some proprietary algorithm to detect the oil sieves and oil leaks that happens within the ships and infrastructure. So they looked at 350 Sentinel scenes in parallel. We ran them through polarimetric processing. That was about 6 terabytes of data, which is quite a bit. Then that was all run through, continue to run through the infrastructure. In this case, with machines with quite some cores, almost 900, and 7 terabytes of memory, and then to deliver the end result, which was in this case a custom algorithm, in under 60 minutes end to end. And this is really, and I hope we all share that this is really what the future of working with geospatial data looks like. It's a simple validation test where in App42 we make it all easy to access, interoperate, and then deliver analytics that bring business to our customers. Okay, so then key benefits and use cases, right? So for partners that bring data and analytics, they see on App42 an additional sales channel. They retain full control on content and on pricing and terms and conditions, and of course they have a secure IP. So anything inside of this algorithm, in these processing blocks, inside of the microservice, as Catalyst refers to it, it's invisible to us, it's invisible to the customer, it's a secure IP. Then for the benefit, for the customer, the benefits are also quite large. You have a one-stop shop for anything geospatial, infrastructure, data, and the processing analytics. You pay only for what you use. You get started with literally zero code running through some of the examples that we provide. Then you use your own algorithms or your own data, and then you scale that using the APIs and the SDK, and all that using an invisible infrastructure that we are handling for you. And as you can imagine, I mean, the use cases are quite wide, right? Like we have companies doing loads of rapid prototyping and automation of those prototypes quite quickly, but then more specific, going into some of our existing customers, they do monitoring, change and object detection, the time series analysis. You can imagine that our customers come up with use cases that we never really expected, which is great. Next slide. Let me see. There you go. I just also wanted to highlight one of our key customers, which is Liveo, which is a company that is been using and working with us for quite some time, and that we hope that companies like Liveo and others will also see not only our platform, but also the processing analytics that we are offering in it as something relevant to them that they would like to benefit, right? Sometimes we refer to it as the leap of faith algorithms that are going to make those customers get so much closer to the end value of their customer. So LiveVO is a company based out of Berlin. And as you can imagine, they work with satellite data to do infrastructure monitoring. They've been using App42 as a platform to get data from a number of data sources, either archived or already available online, as well as tasking. And then they use and run algorithms that get them, again, closer to their specific case. They have customers that are no shy. You see Eon and Deutsche Bahn, and that is really, I'm really happy with this type of customers, because they are the ones that are really delivering the geospatial technology downstream, and it is possible. Here is just a list of the things that they use. They use Copernicus, they use high resolution data, they use digital elevation models, and they also have their own custom algorithms for tree height calculation. So this is just an example that I hope gives you an idea of the type of customers that we have, and that we hope that some of you will become, and will also be using some of the Catalyst Earth algorithms. And then this is funny, because I feel that companies like us that are trying to approach this commercial market have this pricing really upfront. We have a very simple model where you can buy your own credits directly through the platform. These credits can then effectively give you access to a huge variety of options, from data to tasking that data, to run processing, to get the infrastructure, etc. There is obviously volume discounts that can be applied. There is also, custom pricing that can be negotiated as soon as you engage with the sales team. And then this is why I liked from the presentation as well, that we have really this approach to have price estimation for any job. So before you run anything, you are able to see how much that's gonna cost. And that is, it might sound simple, but is quite big, and is quite an innovation that is being brought into this market, to be able to have that flexibility over seeing what you are expecting to pay. Now, we are, as I said, a recent, let's say, a more recent company compared to Catalyst, but we had really good traction. We have 35 plus partners. We have more than 100 blocks on the marketplace. We've had over the history over 2,000 active users, and we have a lot of signups, which is really impressive. And this is all possible not only thanks to the teams here, but also thanks to the partners here. Some of them are listed, and this is a little bit what I wanted to share about App42. And I really encourage everyone to go sign up, get some credits, and explore a little bit what else we do. And now we have one more question, right, Sean? One great survey question.
This is the last survey question, and then we're going to get into our special offer, and then we'll open things up for our Q&A before we can conclude the webinar. Okay, so with this survey question, we're just going to look into, we really want to understand from you what Catalyst capability do you want to see next on the App42 platform. And we have a couple options here, and it's select one. So I'll launch the survey right now. And as you can see on here, so there's a couple, and I'll just walk you through. So we have persistent scatters interferometry, which is essentially our next generation Insar capabilities, which is really more appropriate for infrastructure monitoring. And we actually did a webinar on it 2 weeks ago. So you can look in our recording to see a little bit more about what persistent scatters interferometry is versus, say, Insar that we showcased here today. We also have our very powerful object-based classification and feature extraction, which is sensor agnostic and can be used with both SAR data as well as optical imagery. We have our very exciting analysis-ready data, which we actually promoted with the App42 webinar about a month ago. And this is really showcasing how we can take optical satellite imagery and convert it to ground reflectance measurements that are just immediately ready for analysis. And then we have our some of our bread and butter and capabilities such as satellite and aerial photogrammetry tools for orthorectification, DEM extraction, mosaicing, and then of course other. Is there something else that you'd like to see? And if so, please, we'd love to hear from you. Please specify in the web, or sorry, in the questions panel. Okay, so we have many of you have already voted here today, so I'm just gonna keep this open for another 10 seconds. So if you haven't got your vote in, please do. We'd really love to hear from you and understand, help guide us, help us understand what we should be putting into the UP42 platform next. All right, so I'm gonna close the poll in 5, 4, 3, 2, 1. All right, so let's share those results with everyone. So we have a slight majority of people want to see our object-based classification workflows and feature extraction workflows added to the UP42, about 30%. We have a number of people, 25%, that would really like to see our persistent scatterers interferometry, our PSI workflow, which we just recently launched in general. 13% is analysis-ready data, and then we have another, a large number of you would like to see satellite and aerial photogrammetry tools such as our ortho DEM extraction. So really appreciate this feedback, and we'll certainly provide this to our products team so that we can provide the audience what they want. Okay, so we're just going to go through the final few sections and conclude this webinar now. And this really brings us to our special offer. So we have our ground displacement microservice is now available on UP42. So you can go and check us out, sign in, give us some test run. And in order to help you do that, well, we now have a special offer. So if you sign up now, you can get 10,000 free credits, which is about €100 value. And some conditions do apply in terms of what data sources or microservices you can use them for. But basically, sign up now and you can get this €100 euro value. All right, so with that, we're going to open things up to our questions and answers before we conclude this webinar. And we've had a number of questions that have already come in, and we've done our best to answer those as they have come in. But if you have a question that you'd like to ask either our team or the UP42 team, now would be a great time. So I'd like to invite the other panelists to come back online for the Q&A period. Both Jorge and Griffin, if you can turn on your webcam and join me here. Great, I was feeling a little lonely there for a second.
Here we are.
Wonderful. All right, so I'm going to go through. We have a number of questions here. So I'm going to start off with a really simple one. So Griffin showcased a notebook where he was using our our new microservices and showcasing differential Insar and calculating displacement or creating a displacement map. So the question was, can this notebook be shared with us? And yes, of course. So you can either contact us if you'd like to get early access to the notebook, but the notebook is also going to be available on UP42's website in just a moment. So we're just fine tuning a few things, and then it'll be available on their website. So another question came in about how much time does it take to process the data using this notebook, and this was already answered in the panel, but I think it's a good one for everyone to just understand. And it really depends, because if you're providing a deep stack of imagery, say 10, 20, 30 sentinel scenes, that's really going to change the amount of processing time versus 2 sentinel scenes, as well as the area of the AOI. But maybe to help just give us a bit of an idea, Griffin, can you just let us know, what did it take to process those 2 sentinel scenes? And they were large, full sentinel scenes, were they not?
Yeah, exactly. So those, I processed the 2 full sentinel scenes, and that took about end to end about an hour, 45 minutes for the full workflow.
Yeah. I mean, and if we compare that to, of course, trying to capture that information using ground surveying equipment.
Yeah, of course, it doesn't compare.
It doesn't even compare.
That takes some time.
It would take some time, exactly. And we're also, and this is a good opportunity to just plug that we're also looking at the persistent scatterers interferometry workflow that you know is also one of the areas that we're looking at bringing to the Up42 platform very soon. And this one is going to have some performance improvements because it only processes over the what's identified as a persistent scatterer, as well as there's some other benefits when it comes to certain applications like infrastructure monitoring, which we'll be able to go into in a future webinar. All right, wonderful. So I also just go through another couple questions here. So maybe this is a good one for Jorge to answer. So the question was, how many credits would be consumed by the 60-minute process covered in the previous slide? And maybe that's not even the right way of looking at it. So perhaps you can just help explain a little bit more about the pricing model and that price predictability concept in general.
No, absolutely. I was just chatting and see if I could get the estimate of how much it costs to run this specific example. I don't know, maybe Griffin might have the specific number in general, but the way it works for us is that the platform of Up42 works based on credits. Each credit, it's about 1 euro cent. And effectively, the data that you order, specifically the area of interest that you select within the scene, and then the combination of the processing algorithms that follow is what's going to be consuming those credits. What we do before you click go is we give you an estimation of how much that's going to cost, right? So that I don't know, especially for cases where they are running sometimes hundreds or thousands of jobs in parallel, you have a good estimate of where you are going to land. I would love to give you an answer exactly, Jake, on how many credits did it cost. Maybe that's something that we can follow offline.
Wonderful. Thank you so much, Jorge. Okay, so this will be the last question we're going to be able to answer in the time frame that we have as we're approaching the top of the hour. So this one comes in as, can we please compare this spaceborne approach versus airborne? And what would be the advantages of using spaceborne data for this? So I'm going to help address that. And I actually did already answer it into the panel as well. So essentially, there's a number of benefits for using calculating or measuring ground deformation using spaceborne radar data as opposed to airborne. So one of the advantages is that there's just a lot more studies that have been conducted using spaceborne data for ground deformation. There's more algorithms, more workflows that have been well tested and studied, and validations that have been performed using spaceborne data, and both the commercial as well as public data. So it's just a more well understood and at this point trusted aperture for capturing this kind of data sets or measurements. Another one is satellites are more, another big benefit of this is really satellites are very stable in their orbits. So for this kind of an application, we need to be very precise, we need to be very stable when it comes to sending and receiving those beams, because we're looking for this literally millimeter level phase changes in the return signal. So if the airplane is wobbly on a very, say, windy day, that can very much interfere with the results and produce some inaccuracies. A third one is, well, space-based radar has a large footprint. If you're flying aerial, it's very expensive. You got to commission a plane, you got to fly a variety of returns. Every one of those individual images needs to be processed, analyzed, normalized. Whereas with a space-based radar, we can cover probably the same area, if not much more, with a single image. So it's just a lot easier to deal with space-based. And then finally, satellite data, SAR data, is just more commercially and readily available through open source channels such as Sentinel. So it's far more cost effective to use space-based radar than to, say, commission a plane to go up and capture this information. So hopefully that helped answer some of your questions. And we weren't able to get through every question here. Once again, if we didn't answer your question, We will be posting the answers to all questions that were asked on our website with this recording. So we will get to your question. And with that, I'm just going to conclude here and thank everyone for your time, your participation in our surveys, asking your questions. But I also want to just take a quick moment to really do a special thank you to our special guest, Jorge Fernandez from Up 42. We really appreciate you being here with us today.
Of course, it was a pleasure.
Wonderful. And Griffin, of course, always a pleasure to have you here.
Thank you very much.
All right, on behalf of Up 42 and Catalyst here today, we thank everyone for your time, and we look forward to speaking with you further. Take care.
Thanks.
Have a good day. Bye.